Okay, here we go, graphing quadratics in standard form, and I've got some great news for you. We're going to head over to DESMOS. All right, so this is what the questions are going to look like. We've got a quadratic equation, and it wants to know all these things about it. Well, what we're going to do is we're going to use DESMOS to see what the graph looks like, and then we're going to understand all the different parts of the graph, the characteristics of it. So let's head to DESMOS real quickly. Well, I'm going to. You stay right here. I already put in the DESMOS. Into DESMOS, I put the function, the quadratic, and we know when we put in a quadratic and we graph it, we've seen this before when we did solving using DESMOS for quadratics, that quads look like a U. And I like to goof around. Quads look like a U because you have quads. Haha, you got two of them. All right. So we noticed something, just like we've noticed before, that quadratic graphs are symmetrical, right? We could just slice it in half and we'd have symmetry on both sides. So let's see what our questions. They're asking us for something called axis of symmetry. That's that line that I was talking about that just splits it in half. The other thing they're asking for is vertex, and let's do the vertex first. So the vertex is either going to be the very lowest point or the very highest point. Now let's check. Can we find the very highest point? No, that it's going to go on and on forever, right? So a quadratic's either going to have a min or a max, and this one has a min. And the very lowest point that happens is the min, and we could just hover over it, and it will say, oh, come on, you can do this. You gave it to us before. It said, oh, there it is, -2, gosh, -2, -16. That's our vertex. So let's go over to our paper, and let's go ahead and write -2, -16. All right, I also have the graph here. So we know that this is our vertex, and the coordinate, oh gosh, and the coordinate, we're going to have to do something real quick for me to get rid of this, is just to delete it. Okay, so the vertex is down here, and that point we just said was -2, -16, right? So that means we went over -2. Now, look at our scale. We're going from 0 to 10, so each one of these that's -2, that's -4, right? -6, -8. Okay, so let's talk about what this axis of symmetry is. The axis of symmetry is going to go ahead and, it's going to go ahead and split this quadratic in half, the graph in half. So let's go ahead and get a line going that splits it. Woo! All right. We got to name this line because it's asking us to. So when we look at it, we're like, okay, let me think about this. I remember lines that are, we know this, horizontal lines are y equals 4, or y equals 10, and vertical lines are x equals. Our axis of symmetry is always going to be x equal a number. And you know where we're going to get that number from? Well, we can't see it, but it's our x part of our vertex right here. That's always going to be our axis of symmetry. So first we'll find our vertex, and then we'll see that the x part of our vertex, that's always the axis of symmetry. All right, let's go back over to DESMOS and see if we can find our y-intercept. So the y-intercept is just, hey, where does this graph intersect the y-axis? And so we're going to go back to DESMOS. Okay, I see it right there. It intersects at 0, -12. So if we graph that, right, we would stay on the origin, not go left or right on the x-axis, and go down 12. All right, so we're going to go ahead, and that is 0, -12. Did not mean to do that either. All right, so the y-intercept is 0, -12. Let's pick a different. So that's 0, -12, and we can see it here, right? Our y-intercept is right here at -12. So we're just identifying important things about this graph. All right, solutions. So solutions, that really means if we set this equation equal to 0 and we solved, what would we get, right? We also know that we could call solutions x-intercepts. They both mean the same thing. So let's go ahead and head over to DESMOS, because with mine you can see You can see this is a what? -2, -4, this is -6. So one of my solutions is going to be -6. Now I'm going to put it as a coordinate point, and I think we're going to be okay. If you forget and say x equals -6, what am I going to do? All right, and then here at x equals 2, so that's 2 and 0. All right. Then it's going to ask us something else. It's going to ask us to find the min-max value. Well, we already talked about this. If you've got a low point, the lowest point, that's going to be our min. There's no max point here because this graph is shooting up to infinity. So the min is always going to be the vertex, all right? The vertex is the star. The -2 is the star. If the vertex were our maximum, we would have circled the max. All right, this is where we're talking about increasing and decreasing. So let's see if I can kind of erase some of this stuff so we have a little bit more space. So we want to see, all right, the axis of symmetry is super important. So we want to see where is this increasing and where is this decreasing. So what we're going to do is set up we're going to set up intervals, and we are going to have -2 be the star. Have you noticed that -2 is in everything, right? It just shows up everywhere. So we're going to put our -2 here and our -2 here. All right. We're also going to, so we're trying to include everybody, all the numbers that are on the x-axis. So what we're going to do is we're going to say either, if your number, you're either on -infinity to -2, or -2 to positive infinity. Okay, that's this line right here, this green axis of symmetry actually splits up. Let's get some color so we can kind of see this a little bit better. So this part, the -infinity to -2, that's this part of the graph. Okay, then let's get something orange. This, the -2 to positive infinity, that's this part of the graph. So we just split the graph up into two, and it's split in half right at that -2. All right, one of these is increasing and one of these is decreasing. And all we have to do is do our little trick that we used to do when we found slope, and that is sign our name on the line. If I sign my name on this part, on the blue part, oh, I'm going downhill, okay? That is decreasing. So if I wanted to know the decreasing interval, I'm going to pick that blue one, the -infinity to the -2. So if I want to know the other part, if I write my name on this part, oh, I'm going uphill. Uphill, that's increasing. So the orange side is increasing. And there we go. It looks a little funny writing it interval notation. Can't we just say, hey, the left side's decreasing and the right side's increasing? We could, but in math and the upper level math, we have to use intervals to kind of express ourselves. We just can't just be talking. Intervals can be understood by anybody who speaks any language. All right, talking not so much, right? So one last thing. We got this big table right here. And we can see right here we've got vertex. What color do we do for vertex? So vertex, we already know. Our vertex is -2, -16. And it wants us to fill in a table. It wants us to do 2 lines up from -2 and 2 lines down from -2. Guess who could do that for us? You got it, DESMOS. So let's go back to DESMOS. And how are we going to get a table? Well, we are going to hit this little edit list. And it gives us these options. And look, create a table. Ah, that's perfect. All right, so see how we've got the -2, -16? We're going to use these 2 lower ones. -1, -15, and 0, -12. -1, -15, 0, -12. Let's remember it. -1, -15, and 0, -12. All right, now we need to know the ones that go down this way. Oops, I put them in the wrong thing, didn't I? We're going to be going the other way, -1, -15, and 0, -12. So let's go ahead and erase those right here. Okay, so let's go back to DESMOS. Now we need to see what happens above the -2. So we've got the 2 underneath. Now we need to see what happens above. All right, now I really don't know how to make, let's see if we do this. Oh, okay, we're going in, aren't we? So I don't know how to get the ones that are above the -2 except for to put them in down here. So let's think about it. Let's go back to our thing. If we're going backwards, think about a number line, -2, or just look at this, -2, well, I can't write anymore. So -2, then -3, then -4. So if we want to know what happens there, we just simply go back to Desmos and do a -3, and it tells us -15. Oh, we want to know -4, -4, -12. So it's like, wait a second, those numbers sound familiar, right? -3, -4. So let's put those in. -12 and -15, right? The -12, so the -15 should be the -3. Sorry about that. Let me see. Yep, the -15. Man, I'm just pushing. -15 goes to the -3. And the -4, the -12 goes to the -4. And this makes sense, right? Because we can see we have symmetry. On either side, they're the same. On either side, they're the same. All right, I know this is a lot. We're going to practice together, but we made it through our first one. Thanks for joining me. We will practice, I promise.